1 minute. Hello? Hello? Hello?
Yes, sir.
Yes. Yesterday we are completed Bowley's coefficient of skewness, isn't it? Yes, please.
Yes,
So
sir.
Carl Pearson's coefficient of skewness, SKP, that is mean minus mode, number 1. Number 2, mean minus median. Number 3, 3 into mean minus median. When mode is ill-defined, 3 into mean minus median. Okay. Now, coefficient of Carl Pearson's coefficient of skewness, that is mean minus mode by sigma. When mode is ill-defined, 3 into mean minus median by sigma. Now, Bowley's coefficient of skewness based upon only for quarters. That is first quarter Q1, second quarter Q2, that is median, third quarter Q3, that is upper quartile, Q1, that is the lower quartile. Now, Q3 minus Q1, Q3 plus Q1 minus 2 median by Q3 minus Q1. So, Bowley's coefficient of skewness limits lies in between -1 to +1. Carl Pearson's coefficient of skewness lies in between -3 to +3. Okay. So, these are the completed yesterday's session. Now, today's session, we are going to measure of skewness based on movements. Measure of skewness based upon movements. Okay. That is page number 104. See the page number 104. Measure of skewness based upon movements. Okay. The measure of skewness can be defined by using movements. By using movements. The measure of skewness is obtained by making use of the third moment about the mean, that is mu3. The relative measure of skewness is defined as beta 1 is equal to mu3 square by mu2 cube. That is the formula. The beta 1 nothing but coefficient of skewness. For a perfectly symmetrical distribution, the value of beta 1 will be 0. Why? Because mu3 is equal to 0, so that mu3 0 by something 0, the beta 1 is equal to 0. The greater the value of beta 1, the more skewed is the distribution. It is to be noted that this measure of skewness can never give negative value, because the value of mu2, the value of mu3 may be positive or negative, but mu3 square will be always. So here mu3 square, so beta 1 is equal to mu3 square. mu3 value negative vachina square kabatti positive vastundi. Mu2 cannot be negative. It is our variance. It is always positive. So positive divided by positive, nothing but you should get positive value. So beta 1 value should always positive. Okay. Now next, it is to be noted that this measure of skewness can be never negative. Okay. So as such, the relation of beta skewness, whether positive or negative, cannot be ascertained from the measure of the skewness. In view of the above limitations, Professor R.I. Fisher introduced another measure of skewness, which is given below. Gamma 1 is equal to plus or minus root beta 1. When you are finding the beta 1 value, you should take square root of beta 1 value is nothing but gamma 1. If gamma 1 is equal to 0, then there is no skewness in the distribution. If gamma 1 greater than 0, then there is a positive skewness in the distribution. If gamma 1 less than 0, then there is negative skewness in the distribution. So this is information about skewness. So now coming to next topic, that is kurtosis. If we know the measure of central tendency, dispersion, and skewness, we still cannot form a complete idea about the distribution. In addition to these measures, we shall know one more measure which is known as Professor Carl Pearson calls the convexity of the frequency curve. The convexity, the peak height, that is flatness or peakedness of the curve, of the frequency curve, it is denoted by beta 2. That is nothing but coefficient of beta 2, or it is denoted derivation denoted. It is not derivation, or it's denoted gamma 2 and is given by beta 2 is equal to mu 4 by mu 2 square. Gamma 2 is equal to beta 2 minus 3. When you are finding mu 4 is always positive. Why? Because 1 by n sigma fi into xi minus x bar whole to the power of 4. So when you're getting negative value to the power of 4, nothing but it's the positive. Mute is also positive. So positive by positive is equal to positive. However, beta 2 is always positive value. After finding beta 2, you can calculate gamma 2 is equal to beta 2 minus 3. So curve of type A, which is neither flat nor peaked, is called normal curve or mesocurtic curve. Such a curve is having beta 2 is equal to 3, gamma 2 is equal to 0. Okay. So here is given the diagram C. So this is mesocurtic curve. So this should be known as, so normal curve, which is normal curve plus or minus 3. This is nothing but plus minus 3. This is nothing but minus 3 plus 3. Right side positive, left side negative, which is neither flat nor peaked. అంటే ఇప్పుడు సపోజ్ మన ఇండియన్ పీపుల్ యొక్క హైట్ ఓ నార్మల్ రేంజ్లో ఉంటుంది, 5.4 నుంచి 5.6 వరకు. ఎక్కడో దగ్గర 9.8 అట్లా ఉంటుంది, ఎక్కడో దగ్గర. అది లక్షల్లో కోట్లలో కూడా ఉంటారు కాబట్టి వెరీ రేర్. కాబట్టి నార్మల్ హైట్, ఇండియన్ పీపుల్ యొక్క నార్మల్ హైట్ 5.3 to 5.6 like. Okay. So which is neither flat nor peaked, such a curve is known as mesocurtic curve or normal curve. Such a curve is having beta 2 is equal to 3 and gamma 2 is equal to 0. That is first point. Second one is curve of the type B, which is flatter than the normal curve. So flatter than the normal curve. Normal curve కంటే ఇంకా చిన్నగా ఉంటే that should be normal, which is flatter than normal curve. Such a curve is known as platykurtic curve. Such a curve is beta 2 less than 3 and gamma 2 less than 0. For example, you can take the Japanese. Japanese height is very small, that is 3.4 to 4.5. Like అలా చూడగానే మనకు అనిపిస్తే వీళ్ళు జపానీస్, వాళ్ళ ఫలానా వ్యక్తిని చూడగానే ఇండియన్స్, ఫలానా వాళ్ళు చూడగానే ఇట్లా నిగ్రోస్, ఇట్లా కాబట్టి ఆఫ్రికన్స్ అట్లా. కాబట్టి విచ్ ఈజ్ ఫ్లాటర్ దాన్ ది నార్మల్ కర్వ్. నార్మల్ కర్వ్ కంటే ఇంకా కిందికి వస్తే దట్ షుడ్ బి నోన్ ఎస్ platykurtic curve. Such a curve is having beta 2 is less than 3 and gamma 2 less than 0. That is second one. Type C curve, which is more peaked than the normal curve. Normal curve కంటే ఇంకెక్కువ ఉంటే that should be known as elliptokurtic curve. Such a curve is having beta 2 greater than 3 and gamma 2 greater than 0. సపోజ్ ఇండియన్ పీపుల్ మనం హైట్ బాగా ఉన్నటువంటి ఒక వ్యక్తి 9.6 ఉన్నాడు అనుకోండి. 9.6 అనేటువంటి లక్షల్లో కోట్లలో ఒక్కొక్క దగ్గర ఉంటారు. ఓకే. అటువంటి వాళ్ళు ఏంటిది లిప్టోకర్టిక్ కర్వ్. నార్మల్ కర్వ్ కంటే చాలా హైట్ ఉండదు కాబట్టి లిప్టోకర్టిక్ కర్వ్ అంటాం. సచ్ ఎ కర్వ్ ఈజ్ హ్యావింగ్ బీటా 2 ఆల్వేస్ గ్రేటర్ దాన్ 3 అండ్ గామా 2 ఆల్వేస్ గ్రేటర్ దాన్ 0. సో ఈ డయాగ్రామ్ ఒకటే డయాగ్రామ్ మూడు చూపించాలా. చూడండి, టైప్ సి కర్వ్ లిప్టోకర్టిక్, టైప్ బి కర్వ్ మెసోకర్టిక్, టైప్ ఏ కర్వ్ ప్లాటికర్టిక్. Here is one example is their problem. The first four movements of a distribution about the value 4 of the variable are -1.5, 17, -30, and 108. Find the moment about mean, that is mu1, mu2, mu3, mu4. Beta 1, beta 2. Find also the moments about number 1, the origin, that means a is equal to 0. Number 2, any arbitrary point, that is x is equal to 2 means a is equal to 2. So these are the 3 or 4 points are there in this problem. First of all, the given data is a is equal to 4. At the point a అన్నాడు కాబట్టి the point 4 అన్నాడు a is equal to 4 దగ్గర mu1 prime minus 1.5, mu2 17, mu3 minus 30, and mu3 prime minus 30, and mu4 prime, that is 108. Now coming to central movements, mu2 is equal to mu2 prime minus mu1 prime whole square, the formula. That is mu2 is equal to mu2 prime minus mu1 whole square, that is 17 minus of minus 1.5 whole square. You should get 14.35. Take the calculators. Yes, dear students, take the calculators and simplify it. Be fast. That is mu2 is equal to 14.75. Got it? Answer వచ్చిందండి? Yes, please.
Yes, sir.
Okay. That is 14.75 is the mu2. What about mu1? Mu1 is always 0 for any distribution, whether it is discrete or continuous. Mu1 should always 0. So that here mu1 is equal to 0. Second point, mu2 is equal to 14.75. Third point, mu3 is equal to formula. mu3 prime minus 3 mu2 prime mu1 prime plus 2 mu1 prime whole cube. Substitute the values and simplify it. You should get the answer is, that is 39.75. Be fast. Be fast means you can more practice calculator by using calculator than mobile phone. Mobile phone కంటే ఎక్కువ ప్రాక్టీస్ క్యాలిక్యులేటర్ ఉంటేనే విత్ ఇన్ ద షార్ట్ టైంలో we should complete our calculations. That 39.75. Okay, you can do in your home. And mu4 is equal to mu4 prime minus 4 mu3 prime mu1 prime plus 6 mu2 prime mu1 prime whole square. Only for mu1 prime మాత్రమే whole square. Here you can see the formula. Here you can see the formula 6 mu2 prime mu1 prime only for mu1 prime whole square minus 3 into mu1 prime to the power of 4. Substitute all these values in this formula. You should get mu4 is equal to 142.3125. Clear? Now coming to beta 1, mu3 square by mu2 cube. Substitute the values 0.49. So 0.49 means beta 1 is less than 3. So beta 2 is equal to mu4 by mu2 square, that is 0.65. So mu2 value, beta 2 value is less than 3. This is known as elliptic. When you're drawing the graph paper, the curve should come. The curve is known as elliptic beta 2 less than 3. So this is the first part. Now coming to second part. Now using these mu2, mu3, mu4, you can find the movements about origin, that is a is equal to 0. Movements about origin, that is a is equal to 0. So mean is equal to x bar is equal to a plus mu1 prime. So that is 4 plus a is equal to 4 plus minus 1.5, that is 2.5. So the 2.5 is known as the mean when you are taking the a is equal to 4. Now coming to movements about origin, we are given x bar is equal to 2.5, mu t is equal to 14.75, which are calculated. Mu 3 is equal to 39.75 and mu 4 equal to 142.31. So we know that mean is equal to a plus mu 1 prime. Taking a is equal to 0, that is mean is equal to 2.5, a is equal to 0 in this equation, that is mu is equal to mu 1 prime is equal to mean, x bar is equal to 2.5. So mu 2 prime is equal to mu 2 plus mu 1 prime whole square. So mu 2 is equal to 14.75 plus 2.5 whole square. Substitute in this equation, you should get mu 2 prime, similarly mu 3 prime, similarly mu 4 prime. After that, you can take the moments about the point a is equal to 2. That is mu 1, x bar is equal to a plus mu 1 prime. So x bar minus 2, that is mu 1 prime is equal to x bar minus 2 is equal to 2.5 minus 2 is equal to 0.5. Now you should take mu 1 prime, that is 0.5, that is mu 2 is equal to mu 2 plus mu 1 prime whole square. So mu 2, mu 3 prime, that is mu 3. Again, you can calculate these 4 values. Okay. Now example. The first 4 movements of a distribution about value 5, minus 4, 22, minus 117 and 560. Find the corresponding movements about the mean, that is mu 1, mu 2, mu 3, mu 4. Also find beta 1 and beta. Do the problem. Out of this model, we should get one problem is there in our question paper, which is very most important. Now coming to second model. So this is the second model. Calculate the first 4 movements about mean for the following data. X is given 11, 13, 14, 15, like so on and so forth. Frequency is given. Now, first for this point of view, we should calculate mean value f into x. Sigma of x is equal to 140. D is equal to x minus x bar. X bar is equal to, that is 14. We are calculating here, mean is equal to x bar is equal to 1 by n sigma fx. So 140 by 10 values are there. 10 is the frequency, sum of frequency is equal to 10. So that 140 by 10 equal to 14. So d is equal to x minus x bar, that is 14, fd and fd square and fd cube for third moment. So here the printing mistake is there. This is the not capital F. So here, this is not capital F. That should be known as small f. Dear students, please correct the symbol. You should write only for small f, should not write capital F. Because small f is known as frequency. So fd cube like fd4. Okay. Right. So here, mu1 is equal to 1 by n sigma fd is equal to 0. చూడండి fd ఎంత వచ్చింది 0 వచ్చింది చూడండి. So sigma fd by n equal to 0. That means mu1 always 0. For any problem, the first central movement should always 0. Mu2 is equal to 1 by n sigma fd square, that is 18 by 10, that is 1.8. Mu3 and mu4, and coming to, thus the 4 central movements are mu1, mu2, mu3, mu4. So that is the first problem. Here is check your progress. Number 1 problem is there. Number 2 problem is there. Number 3 problem is there. Number 4. So these are the exercise problems you can do. Summary coming to model examination questions. Model examination questions. Define central non-central movements. Derive the relation between them. Show that the movements are independent change of origin but not scale. Explain Shepard corrections for movements. What is the skewness? Explain various measures of skewness. Explain measures of skewness based upon movements. The short questions, define central non-central movements. Write a short notes on skewness. Explain Carl Pearson's coefficient of skewness. Explain Bowley's coefficient of skewness. What is kurtosis? And write a short note on kurtosis. Write a short notes on kurtosis means nothing but you should write definition of kurtosis and what are the models type 1, type A, type B, type C. ఉన్నాయి కదా diagrams సహా వాటి గురించి రాయాలి. These are the important questions in unit number 6. Block number 2, we are having 3 units. Block number 2, we are having 3 units. One is known as measure of central tendencies. and one is known measure of dispersion, and one is known as measure of movements. So up to here we are completed. We are completed block 2 up to block 2. That is 6 unit is completed. Now coming to block 3 in our syllabus, in our textbook, the block 3 is known as addition rule. Block 3 is known as addition rule. Okay, so that is the probability. Clear? Yes, please. Any doubt? Wait for 1 minute.
Sir, please send me important notes on WhatsApp, sir.
Important notes, nothing but we are having the textbook. That is a we can follow the textbook simply. After complete of unit, we are having the questions are there. Just now I read questions. That are the important questions.
Okay, sir.
Theory part.
Sir,
Okay.
sir, can we practice in model test papers, sir?
You can practice it. It is available in Hyderabad, I think so. That the B.R. Ambedkar test papers.
Yes,
You can
sir.
search bookstores.
Okay.
Okay.
Okay, sir.
Okay. 1 minute. Okay. Dear students,
Yes, sir.
next we are going to third block. In third block, that is the probability. Third block is nothing but shortcut probability. In probability, we are having three units are there. One is definition and basic concepts, and one is addition theorem of probability, and one is some more important theorems. So this block 3 and block 4 is based upon only for probability, and block 3 is known as addition rule, and block 4 known as Bayes theorem. Okay, isn't it? Now coming to open your textbooks. I am not having the material, okay, in this block 2 and block 4. So now coming to unit 7, that is definition and basic concepts on probability. Okay. So definition and basic concepts is the 7th unit, and theorems of addition rule of probability is the 8th unit, and some more important theorems in 9th unit. So we will complete 7, 8, and 9. We will complete the basic concepts on probability. Now coming to unit 7, definition and basic concepts. So in definition of basic concepts, the basic terminology used in probability. So first of all, we discuss about experiment, an activity that yields a result of an activity that yields a result or an outcome is called an experiment. When you're tossing a coin, when you're tossing a coin is known as the experiment. If you are getting tail or head are known as the event. So second example, you are attending the examination is known as experiment. Getting pass or fail is known as event. Third example, attending the function is known as experiment. Success or failure is known as events. Like you can take the examples. So any experiment is nothing but what? An activity that yields a result or an outcome is called an experiment. Random experiment, if in each trial of an experiment conducted under identical conditions, the outcome is not unique, but may be any one of the possible outcomes, then such an experiment is called a random experiment. Suppose when you are taking one coin, you can toss 5 times. First time you should get head. The second time definitely you should get head or tail, but definitely we will get head or definitely we will get tail, and that is not depending on the previous knowledge. So the experiment conducted are identical conditions, are essential conditions, and those results may not be predicted beforehand, but it will come possible outcomes. Whether it is kind, you should take head or tail. At an examination, you should get tail or pass or fail, like so on and so forth. That should be known as random experiment. Example, tossing a coin, throwing a dice, drawing a card from pick of 52 cards. So you are having the knowledge of these three items. One is coin, second one is dice, and third one is playing cards. Coin is having two tails. One side is head, the other side is tail. Okay, isn't it? Now dice. Any dice will have 6 faces. 1, 2, 3, 4, 5, 6. Card. Any playing cards set is known as 52 cards. Out of 52, excluding 2 jokers, not including, excluding 2 jokers, we are having 52 cards. Out of 52 cards, we are having 4 categories. One is love symbol, heart, and one is leaf, and one is pool, and one is diamond. Each category will have 13 cards into 4 equal 52. Out of 13 cards, we are having 1 oblique Ekka. Second, 2, 3, 4, 5, 6, 7, 8, 9, 10. The next one is Jaki, 11, Q, 12, and K, that is 13. And Ekka is also using for 1 oblique 14. Or you can use 1 as well as you can use 14, that is Ekka. So we are having 4 categories into 13 cards equal to 52 cards. You have the minimum, you know the minimum knowledge of these 3. One is kind, one is dice, one is card, playing cards. Now outcome, the result of random experiment is called an outcome. Trial, conducting a random experiment is called a trial. Tossing a coin is a trial or random experiment. Sample space, the set of all possible outcomes of a random experiment is called sample space. It is denoted by S or omega, whatever you can say. When you're tossing a coin, that is S is equal to head or tail. When you're attending the examination, S equal to set of pass or fail. When you're attending the function, S is equal to success or failure. Like you can take the sample space denoted by S. The set of all possible outcomes of a random experiment is called sample space. It is denoted by S or omega. Example number 1. If a coin is tossed either head or tail appears, the sample space is S is equal to set of H comma T. If a second example, if a dice is thrown, all possible outcomes is 1, 2, 3, 4, 5, and 6, then the sample space is equal to set set of 1, 2, 3, 4, 5, and 6. Now next, event. These are the basic terminologies. I will explain the basic terminology, basic terms, which is given block number 3 and block number 4. Event. The possible outcomes of a random experiment are called events. That is, may element or member of sample space is an event. Event or elementary events. Okay. An event which corresponds to a single possible outcome of an experiment. That is, it is an outcome of a random experiment, that it cannot be decomposed further into smaller events. When a dice is thrown, each of the outcomes 1, 2, 3, 4, 5, 6 is an elementary event. When two coins are tossed, the event 2 heads is an elementary event. So when you're getting two heads, when you're tossing 2 coins simultaneously, you should get 2 heads or 2 tails are known as elementary events. An event which is not simple or elementary is called compound event. Every compound event can be represented by the union of a set of elementary events. When a dice is thrown, an event getting an even number is composite, consists of elementary events 2, 4, 6, like so on and so forth. Exhaust events. The total number of all possible outcomes of a random experiment is known as exhaustive events. So in a probability, the first point is trial and event. Second one is exhaustive events. In rolling a dice, there are 6 exhaustive events, 1, 2, 3, 4, 5, and 6. In tossing a coin, there are 2 exhaustive events, head and tail. If tossing an unbiased coin, head and tail are equally likely events. So what is the meaning of unbiased coin? And what is the meaning of unbiased dice? And what is the meaning unbiased life? So first of all, we can discuss unbiased coin. Suppose I have taken one coin. That coin tossed 6 times. Out of 6 times, you should get equal 3 heads and 3 tails. If you come to 3 heads or if come to 3 tails, is known as unbiased. First tossed, head is given. Second tossed, tail. Third tossed, tail. Fourth tossed, head. Fifth tossed, tail. Sixth tossed, head. Out of these 6, 3 heads, counted 3 heads and 3 tails. So the number of success equal to number of tails, number of failures, or the number of heads equal to number of tails is known as unbiased coin. Okay. Now coming to, suppose out of 6, we are having 4 heads. We are having 2 heads, 2 tails. So 4 heads, 2 tails means 6. So, but 4 heads to 2 tails are not equal. So that should be known. The coin is known as Not unbiased means it is biased kind. అంతేగాని కైన్ పైన రాసి ఉండదండి. కైన్ పైన అన్బయాస్డ్ అని చెప్పి బయాస్డ్ అని చెప్పి రాసి ఉండదు. కానీ ఒక 6 సార్లు మన కైర్ ఎగర వేసినప్పుడు 3 సార్లు హెడ్ కానీ 3 సార్లు టైల్గా వస్తే అది ఎక్కడ రావచ్చు, 1లో రావచ్చు, 2లో రావచ్చు, 3లో రావచ్చు, 4లో రావచ్చు, 5లో రావచ్చు, 6లో రావచ్చు. వస్తే దట్ షుడ్ బి నోన్ అన్బయాస్డ్ కైన్. క్లియర్? నౌ వాట్ ఈస్ ద మీనింగ్ ఆఫ్ అన్బయాస్డ్ లైఫ్? So problem is given to me, solution is there, God is given solution, and again come to problem. మనకు రోజు ప్రతిరోజు ప్రాబ్లం రావాలి, సొల్యూషన్ దొరకాలి. ఇవాళ 5 ప్రాబ్లమ్స్ వచ్చినాయి, 2 1 minute. Okay, so here that should be known as unbiased life. Means what? Today we are having 5 happiness scenes, 5 bad scenes. So that should be known balanced. Today we are having 2 happiness scenes, 6 bad scenes, not balanced. So that should be known as more depression. More happiness is also not good, more depression also not good. So you should have balanced. In our calendar, we are having 15 days Paurnami, 15 days Amavasya. So that should be known, the calendar is known as unbiased calendar. Whatever the life and whatever the experiment, we are having equal number of heads, equal number of tails. That should be known as unbiased kind antam. Okay. So in statistics or in probability, we are having unbiased is the most important. Now, second one is favorable, third one is favorable events. When you're tossing a coin, when you're throwing a 2 dice, the sum of the points on 2 dice 4. That is 1, 3. 1 plus 3 equal to 4. 2, 2. 2 plus 2 is equal to 4. 3, 1. 3 plus 1 is equal to 4. How many events are there? Only 3 events. That is 1, 3 is the 1 event. 2, 2 is the 1 event. 3, 1 is the 1 event. So total is 3 events. So that is known as favorable events. The number of cases favorable to an event in a random experiment is the number of outcomes which entail the happening of the event. In throwing a dice, the number of cases favorable to getting an even number is 2, 4, 6. In drawing a card from a pack of cards, the number of cases favorable to drawing a diamond is 13, and for drawing a black card is 26. Okay. Now, fourth one is independent events. So, what is the meaning of independent events? So, independent events means, suppose I have taken the coin, tossing 5 times. First time I getting head. Second time I will get head or tail. It is not depending upon the first time. So ultimately we should get tail. First time head, second time tail. Again toss it to my coin, third time I will get head or tail. It is depending upon the second and first. So that should be known as independent events. Okay. 2 or more events are said to be independent if the happening or non-happening of an event is not affected by the happening or non-happening of the other events. Example, if a coin is tossed twice, the result of second toss does not depend upon the result of first toss. If a dice is twice, the result of the first throw does not affect the result of the second throw. An event is said to be sure event if all the possible outcomes of an experiment are favorable to the event. That is, P of E is equal to 1. Then E is called sure or certain event. Suppose in our class, the strength is 40. Today class, 21 students are present. So, P of E is equal to favorable number of events, that is 21, divided by exhaust event, that is 40. So, 21 by 40 is equal to is the probability of success. How many students are attended today's session? 21 people. So, 21 divided by total is 40. That is P of E. Now, how many students are not attended the session? 40 minus 21, that is 19 students are attended. So, probability of E bar means probability of failure equal to Q by equal to favorable number of events not attend the classes 19 by 40 to exhaust events 40, 19 by 40 is equal to probability of failure. 21 by 40 is equal to probability of success. You can add it. So, 21 by 40 plus 19 by 40 is equal to 40 by 40 is equal to 1. So, out of 40, the 40 students are attended the class. They need not to take the attendance. Why? Because favorable events is 40, exhaust events is 40. So, 40 by 40 is equal to 1. So P of E is equal to 1. That is known as sure event or certain event. So, the probability can apply only for uncertainty. In our society, we are having two types of events are there. One should be known as certain event. One should be known as uncertain event. Certain event nothing but throughout India, we are having today is Sunday. In USA, they are having midnight of Saturday. In some states, midnight of Saturday. Because we are having 12 hours of difference to Indian and USA. Okay? ఇక్కడ ఏంటిది 2 into 2 is equal to 4. 2 అంటున్నాం. 2 into 2 is equal to 4 in entire world. In entire world, 2 into 2 is equal to 4. In entire world, every day 24 hours. In entire world, every hour will have 60 minutes. Okay? Every hour will have 60 minutes. Every minute will have every day will have 24 hours. Every hour will have 60 minutes. Will have 60 minutes. Okay? So, like this is not a certain event. We cannot apply probability for certain events. We can apply only for uncertainty. Uncertainty means which are today we are studying, we are interested, may or may not be happen to study, may not be happen to attend the classes, may or may not be attended to function. Like this is known as uncertain events. So, probability can apply only for uncertain events. Suppose our class 10th is 40 attended, the P of E is equal to 1. That should be known as E is known as sure event or certain event. Out of 40, nobody student are not attended. That means 0 attendance. So, 0 by 40 is equal to 0. So, P of 0 is equal to 0. That is known as impossible event. That is event is known as impossible event. Now, coming to fundamental rules of counting. That is, in probability, we are having permutations, combinations. So, permutation nothing but NPR. So, NPR means permutations. NCR means combinations. NPR is equal to n factorial by n minus r factorial. The factor nothing but n factorial nothing but n into n minus 1, n minus 2, like so on and so forth. That should be known as factorial. 3 factorial means 3 into 2 into 1. 5 factorial means 5 into 2, 4 into 3 into 2 into 1. Like decreasing order. 0 factorial means 1. 1 factorial means 1 minus 1 is equal to 0. That is factorial concept. So, we are having in probability, we are having the factorial concept, number 1. Number 2 is permutation concept. Number 3 is combination concept. So, first one is factorial concept is over. The second one is permutations. NPR, that is n factorial by n minus r factorial. NCR, n factorial by n minus r factorial into r factorial. This is given in 10th class mathematics. NCR means n factorial by n minus r factorial into r factorial. So, that is the basic knowledge of factorial, number 1. Number 2, permutations. Number 2, combinations. Now, coming to definitions of probability, we shall discuss the following definitions of probability. One is mathematical or classical or a priori probability. Here is a Printing mistake there. See the notes. Number 1, mathematical or classical. You should write or. A priori probability. We are having 3 types. One is mathematical probability, or classical probability, or a priori probability. A priori means from the cause to effect. When you are having the electricity current, having the current, you can switch, you can on the fan. Switch button is on, the fan is running. If there is no current, switch button is on, but the fan is not running because current is no current, no power is there. So how the fan is running? No running. So that from effect to, from cause to effect, కారణం నుండి ప్రభావానికి అంత ఏమంటాం మనం a priori probability అంటాం. The second one is statistical or empirical probability. Third one is axiomatic approach to probability. So these are the types of 3 probabilities. One is mathematical or classical or a priori probability. Second one is classical or empirical probability. Third one, axiomatic approach to probability. Now, number 1, mathematical or classical or a priori probability. If a random experiment has an exhaustive, mutual exclusive and equally likely outcomes out of M are favorable to the occurrence of event E, then the probability of occurrence of event E is denoted by P of E and is given by P of is equal to number of favorable cases by total number of exhaustive cases small m by small n, and the probability that the event E does not occur will be that is. So just now I explained example. We are having the fastest 10th, but today 21 students are present. So favorable events is 21 by 40. So P of is equal to 21 by 40 is known as probability of success denoted by small p. Now, how many students are not attended the classes today's session? 19 students are not attended. So that P of E bar equal to number of favorable to attend, number of favorable to not attend the session class today class 19 by exhaustive events is 40. So P of E bar equal to 19 by 40, that indicating small q. So that P of E plus P of E bar is equal to 1. Since M number of favorable cases, clearly M should be less than or equal to N and N greater than 0. That is the limits of probability that 0 less than or equal to P of E less than or equal to 1. So exactly if you get the P of E is equal to 1, that should be known as Uri event or certain event. Exactly you should get P of E is equal to 0, that is known as impossible event. But P of E lies in between 0 to 1. We are not having the negative values, the positive values 0 to 1. Okay, here I can stop. So the remaining should continue. If you have any doubts, yes, please. Having any doubts? Speak. Anybody respond? Hello, dear students.
No,
Sir.
sir.
Hello.
Sir.
Okay. Varun is given no answer. No, sir. Varun is given no answer. Okay. Thank you. So you can prepare well and you touch with me my mobile number, which is already given to you. If you are having any doubts, ask any time. Okay.
Sir, today is the last class.
Answer. In between only for evening 7 lopalne phone cheyandi. Okay. Right. Tomorrow we can share. So the class is over.
Sir, this is the last class. Sir, can you please give me a number, sir?
Hello, anybody have sir number?
గ్రూప్ లో ఉంది.
Group లో.
ఏ గ్రూప్ లో?
Stats group.
Please share. Please add me in that group. Link send చేస్తారా ఒకసారి స్టాట్స్ గ్రూప్.
సార్ నెంబర్ చెప్తారా?
గ్రూప్ అడ్మిన్ సారా? Hello, is there anybody? Hello.
సార్ నెంబర్ టెక్స్ట్ చేస్తున్నాను, సేవ్ చేసుకోండి. సార్ నెంబర్ వచ్చింది కదా, ఓకే.
ఈరోజు లాస్ట్ క్లాసా?
లాస్ట్ క్లాస్.
ఓకే థ్యాంక్.
హలో బ్రదర్,
చెప్పండమ్మా.
లాస్ట్ క్లాసెస్ నోట్స్ ఏమన్నా ఉందా?
నోట్స్ ఏం లేదమ్మా, టెక్స్ట్ బుక్కే క్లియర్ ఉంది.
ఓకే, మీరు బిఎస్సి కంప్యూటర్స్ ఏనా మీది?
కంప్యూటర్స్, మ్యాథ్స్, స్టాట్స్.
ఓకే, ఈ మూడింటికి సెపరేట్ ఇది గ్రూప్ చేశారా? వాట్సాప్ గ్రూప్.
కంప్యూటర్ స్టాట్స్ కి అయితే సపరేట్ ఉంది.
ఓకే.
మ్యాథ్స్ కేమో మొత్తం కాంబినేషన్ లో ఉంది.
ఓకే, ఆ లింక్ కూడా ఒకసారి సెండ్ చేస్తారా?
అవి లింక్స్ నేను చేయలేను, మీరు డైరెక్ట్ గా నెంబర్ కి మెసేజ్ పెడితే వాళ్ళు సేవ్ చేస్తారు, వాళ్ళు యాడ్ చేస్తారు.
ఓకే, ఎవరికి చేయాలి?
ఒక్క నిమిషం. ఏంటి, మ్యాథ్స్ కంప్యూటర్స్?
మ్యాథ్స్. ఇప్పుడు ఆల్రెడీ మీరు ఒకటి సెండ్ చేశారు కదా, అది స్టాట్స్, ఓన్లీ స్టాట్స్?
అది ఓన్లీ స్టాట్స్.
ఓకే, కంప్యూటర్స్, మ్యాథమెటిక్స్ కావాలి.
కంప్యూటర్స్ ఆ నెంబర్ కి మెసేజ్ చేసి 2021 బ్యాచ్ కంప్యూటర్స్ అని టెక్స్ట్ చేయండి, మీకు లింక్ వస్తుంది, జాయిన్ అవ్వండి.
ఓకే. ఇది కంప్యూటర్స్ కి, మ్యాథమెటిక్స్ కి? హలో.